Hello students, we're going to go over section 1.3, precision and accuracy. So as we go through this, we're going to talk about finding the minimum and maximum possible areas. In order to do that, we're going to round to half a unit more than what it has. So if I look here, we want to find this. This is 28.3, that's the 10th place, so we just go a half a unit past that. So half a unit, so that's the 10th place, and then we go 1 unit to the right, so that would be 0.05 or half a hundredth. So then we go here, this is round to the 1 place, so we go 1 unit to the right, so that would be that would be to the 10th place, half a unit of that, so 0.5. So then all we do is we add and subtract that to it. So you take that 28.3, and we would subtract 0.05. We take the 28.3 and we add 0.05. So that would be 28.25 to 28.35. If we want to find the maximal area, to find area, it's length times width. All right, well, we'll leave it there, okay? So then we take the other one. We go 21 minus 0.5 and then 21 plus 0.5. So that would go from 20.5 to 21.5. So these would be my minimum areas. And so we're going to that's my minimum length and minimum width. So now to find the area of that, we multiply them. 28.25 times 20.5. So when we go ahead and do that, we have 28.25 times it by 20.5, and we get 579.125, and this would be in centimeters squared. To find the maximum, we take our two larger values, 28.35, times it by 21.5, so times it by 21.5. So 28.35 times it by 21.5 equals 609.525 centimeters squared. So this would be the maximum area, and this would be my minimum area that I could have. We'll do one more of these. So again, this is rounded to the 10th place, so I just go one past that, so that would be 0.05. This rounds to the 1th place, so I go to the 10th place, 0.5. So then we subtract it, 5.5 minus 0.05, and then 15.5 plus 0.05. Then we come through here, we go 10 minus 0.5, and then 10 plus 0.5. So when we do that, when we subtract it, we get 15.45 to 15.55. Here, 10 minus 0.5 is 9.5. 10 plus 0.5 would be 10.5. So we're going, again, matching up our minimum, 15.45 times 9.5. So we multiply those together, and when you do that, we get 146.775, and this would be in centimeters squared. And then we're going to multiply our maximum together, so 15.55 times 10.5. Is 163.275 centimeters squared. Again, this is our minimum area, and this is our maximum area. Next, we're going to talk about significant digits. So we have a number of rules for it, all non-zeros. So anything that's not 0 will be a significant digit. Anything that's between two significant digits, so as long as we have a significant digit on either side, we count the 0. If the 0 is at the end of the number to the right of the decimal point, then we count it. Any zeros to the left of the first non-zero digit in the decimal are not significant. To the left of the first non-zero in a decimal, okay? So as we look at it, there's no significant digits. Okay, as long as there's no significant digits in front of it, we wouldn't count it. And then lastly, if there's no decimal point, zeros at the end of the number are not significant. So here we count 1, 2, 3. Always count the non-zeros. Then this zero is between it, so we count this one. This, and this are between it, so we count those. So we have 1, 2, 3, 4, 5, 6, 7, 7 significant digits. Here we count the non-zeros, 1, 2, 3. This zero and this zero are between it, so we count those. That zero is at the end, so you don't count that one. And I should say, you shouldn't count that one. So that's 1, 2, 3, 4, 5. 5 significant digits. Okay, you come through here, you count your significant digits. So that one and that one's easy. This is to the left of it, so you don't count that one, don't count that one. So we have 2 significant digits. Here you count the non-zero. There's no decimal point, they're all to the right, so that would be 1 significant digit. Last one, you have it here, and then it's to the right of the decimal point, so we count these ones. 1, 2, 3. Well, this one's between it, so you count this one is here. So that's 5 significant digits. Okay, here the student claimed, as you look at it, okay, so these ones here to the right of it, so that doesn't count, that doesn't count. So there would be 2 here. You look at this one, same thing, those don't count. There's 2 here, so the student is correct. Last one as you go through it. So the sum of the differences be rounded to the same place value as the last significant digit of the least precise one. So what this means is we're going to go ahead and we want to find perimeter. So to find perimeter, so just to give you a picture, this is 22.3 and this is 75. So we're going to add these all together. 22.3 plus 22.3 plus 75 plus 75. So we add them all together. And we add them and we get this to equal 194.6. Now it says round to the same place value as the last significant digit of the least precise measurement. So if I look at this has 2 significant digits, that has 3 significant digits. Okay, so we're going to go with this one, okay, of the least precise measurement, that'd be 75. Okay, and then it says we're going to the last significant digit. It rounds to the ones place, so we're going to round here. So it'd be 195, and this is feet. To find area, we just multiplied length. So this is how we find area. So we multiplied 22.3 times 75. And we get 1,672.5. So let's look at a rule. The product or quotient must have no more significant digits than the least precise measurement. Again, the least precise is 75. Okay? Then it says must have no more significant digits. This has 2 significant digits, so you just count 1, 2, and we got a round here. So we'd say 1,006. The 6 would round up to a 7, and then we go 0, 0. No decimal point, because if I add decimal point, then I'm going to add numbers to it. So again, if I did this, regular pot measures 21 feet. So again, we have this 21 feet by 25.2. This is my least precise measurement. So now that we know it's the least precise, to find the perimeter, I add them all up. When I do that, then I'm going to go ahead and get 92.4. All right, this is rounded to the ones place, so I round this to the ones place. So that 4 tells me to stay there, so that's 92 feet for the perimeter. And then for the area, I'm going to go ahead and multiply length times width. And I get 529.2. Again, we only have 2 significant digits, so we go right to here, to that 2. And then what comes after is a 9, so that would be a 53, 0. So it'd be 530 feet squared. So that's how we go about using significant digits in accuracy as we look to it.